Let's go.
Pixel Play, a venture initiated in 1999 by a group of passionate gamers, Andrianica Culli, Deborah Cavaleiro, Guilherme Rossat, Manuel Gonçalves, and Sebastião Rosalino. This business distinguishes itself not only through its virtual marketplace, but through the complications of its relational database. This analytical overview delves into the structural foundations and the interplay of tables, as it would be outlined later in the SQL script. Our business relies on a relational database for effective data management and organization. This structured approach ensures that essential information of our online business is efficiently stored and easily retrievable. This information includes details about each video game like title, description, release date, price, genre, publisher, and platform. The use of primary keys, foreign keys, and constraints in relational databases maintain data integrity, and so we manage to prevent errors and inconsistencies. Furthermore, relational databases enable the establishment and maintenance of relationships between various entities, such as publishers and platforms, streamlining the organization of interconnected data. This relational structure is crucial for executing complex queries, generating reports, and analyzing customer preferences, contributing to the overall efficiency of our online store.
Let's dive into the core tables. Let's dive into our core tables and their pivotal attributes. Firstly, the log table. This table is a vital component for tracking database activities, as it stores event descriptions and timestamps, ensuring transparency and accountability in data management. Secondly, the customer and address tables. These tables are intertwined, and they are very important. The customer table captures essential customer details, while the address table stores their geographical information, enabling us to understand and serve our clientele better. Thirdly, the order and order detail tables. These tables lie the essence of our business transactions. The order table tracks each sale, and the order detail table delves into the specifics of every transaction, providing a granular view of our sales. Fourthly, the supplier and supplier order tables. These tables are key to our inventory management, linking suppliers to their orders and ensuring a smooth supply chain. Now, moving on to the critical aspect of our design, we refer to the strategic use of the on-delete and the on-update constraints. In the customer table, on-delete restrict for address ID ensures that customer addresses are not inadvertently deleted, maintaining the integrity of our customer data. In the order detail tables, on-update cascade and on-delete restrict ensure that any changes in orders are accurately and automatically reflected in the order details, while preventing the loss of crucial order information. The supplier order table uses on-delete restrict for supplier ID, preventing the removal of suppliers with active orders, crucial for our inventory stability. Crucially, in our video game tables, we have employed a on-delete set null for the attributes genre ID, publisher ID, and platform ID. This decision allows us to preserve the continuity of video game records, even if these associated genres, publishers, or platforms become obsolete. This is a thoughtful approach that ensures our database remains adaptable and resilient in the face of the dynamic nature of the gaming industry, ensuring we keep selling video games already in stock. Just to finish, these decisions are the safeguards that maintain the consistency and reliability of our database, ensuring that it truly supports and enhances our business operations.
For the trigger section, let's start with the create supplier order. This trigger starts verifying if the stock quantity is below or equals 0, then create a supplier order, else just update the quantity stock. For the second trigger, automatically insert the event description in log table every time inventory gets updated. For the third function created for specific test our trigger. The first one, the create supplier order. This function needs two arguments. The first one is the video game ID. The second is the quantity. Basically, this simulates a buy. So every time this function is called, insert automatically a order, then update the inventory. For the first and for the last trigger, we have the after insert in order. So every time one order happen, inserts automatically event description. So to test our triggers, in first select we have the quantity, the second select we have the orders, in the last one we have the supplier orders. So calling this function, we can see right now you have 0 quantity, a order made by the client, and the last one, the supplier order.
For the dummy data, the primary goal on this step was to simulate a diverse range of transactions. To accomplish this task, we used randomly generated data relevant for each of the inserted features. The data insertion process involved the creation of the employee records and also a customer base, as well as the introduction of gaming-related entities. The central video game table was then populated with various game titles and details. Transactional aspects were addressed through the insertion of the orders and inventory data, capturing essential information related to customer orders, supply chain logistics, and stock quantities. Finally, customer feedback became an integral part of the database through the rating table recording reviews and associated dates.
The first query involves joining tables and filtering data based on a date range. The key optimization strategy here is indexing the order date column in the order table. This is essential because the query's performance relies heavily on quick access to order data for date range filtering. By indexing order date, the database can efficiently navigate through data within the specified range, thereby significantly reducing query execution time. And then an indexed order date ensures the database maintains its performance and handles large datasets effectively. The second query counts the number of orders made by each customer and selects the top 3 customers based on the number of purchases. The optimization analysis shows that the execution plan doesn't suggest any index creation, and the speed of the query is considered fast and is sustainable for future data growth. Therefore, no index creation was deemed necessary. The third query involves joining tables to aggregate sales data and calculate averages over a specific period. The optimization strategy here leverages the indexed order date in the order table. The index on order date significantly enhances the query's ability to swiftly filter records within the set period, which is vital for efficient data aggregation, especially in large datasets. The fourth query calculates total sales by geographical location. The optimization analysis shows that the execution plan doesn't suggest any index creation, and the speed of the query is considered fast and is sustainable for data growth. The fifth query involves multi-table joins with grouping based on location, product, and ratings. The optimization strategy here includes creating indexes on video game ID and customer ID in the ratings table. These indexes significantly enhance the joint performance between the rating, video game, and customer tables. They enable rapid lookups, thus reducing the time taken to execute complex join operations. Such indexing is particularly beneficial as the number of ratings grow, ensuring that the database can efficiently manage and query the increasing volume of data.
Views have been created to replicate the information present in an invoice within the database. The first view, named Head Totals View, consolidates head and totals information, providing a summary of the client details, address information, company placeholders, and specific invoice details. This view involves joint operations on customer, address, zip code, order, and order details tables. It groups information by client name, company details, and invoice number. The second view, referred to as Details View, focused on itemized details for the invoice. It retrieves information such as video game titles, unit costs, quantities, and total amount for each item. Similar to the first view, it involves join operations on order details, and video game tables. Finally, the select clause specifies the columns to be included in the view, presenting a breakdown on individual items. Now we finish our presentation. Thank you for your time.